Hello, this is Travis Duncan, and this is the Mech 120 Pneumatic and Hydraulics Final Project, the Pneumatic Ladder Climbing Robot. The goal of this project was to create a robot driven by pneumatics to climb a ladder. The name of the robot is the iHopper. I did this project with Chelsea Biggis, and this is the first phase of the project where we had our initial design and testing of our electric pneumatic robot. We used Vex components as well as Festo components found in our TP201 kits. Here's our initial design. We used two dual acting cylinders on each side to extend the robot, and we used a pancake cylinder to grab onto each rung, and we had a hooking mechanism at the bottom. As you can see here, we're using push buttons to do our first initial testing. Unsuccessfully, as you can see. The two cylinders on each side are extending the robot. We retract the pancake cylinder on each rung and then extend it in order to grab onto each rung, and the hooking mechanism underneath was supposed to hook on the rung previous. As you can see here, it wasn't very effective. We couldn't do it in record time. So we knew that the initial design of it was very flawed. It needed to be redesigned. So here's the phase 2 redesign. As you can see, we've threw out the other dual acting cylinder, and we only used one cylinder to drive it. And we added a second pancake cylinder on the bottom, so that we'll have one pancake cylinder at the top grabbing onto each rung, and another pancake cylinder grabbing on the bottom rung. Right here I'm wiring up the push buttons into the relay box, and using the Festo equipment hooked it to three separate directional control valves that are controlled electrically through solenoids. And here's our phase 3 troubleshooting of our new design. As you can see here, we're having a little bit trouble with our new design. Through troubleshooting, we found that the reed sensors, the Festo reed sensors on the cylinder that we were using to activate each of the pancake cylinders was not working properly. As you can see here, as I adjust it, it picks up where the location of the dual acting cylinder is. But we had to go back and with electrical tape secure the reed sensors on each end of the dual acting cylinder. And here's our phase 4 presentation after the troubleshooting and the correcting of the reed sensors. As you can see, it's a lot more effective. You can see each pancake cylinder extending and retracting depending on where the dual acting cylinder is and where the reed sensors can pick it up. Here it is in slow motion. Each pancake cylinder grabbing onto each rung. And here's the last phase, our race day. And here it is at full speed.
Hold on.
As you can see, it's a lot faster, a lot more efficient, a lot more effective. Our final clock-in time was 3.2 seconds, which is pretty fast compared to our initial design. And thank you for watching.